Well, welcome back. This is Mr. Reeves again, and this is a second video in a short series of videos on polynomials. So we had our first video, which was an introduction to polynomials. This one is going to be about adding and subtracting polynomials. All right, so adding and subtracting. So it'd help if I could spell, huh? Oops, don't like it when it does that. Adding and subtracting polynomials. All right, so in the previous video, the previous video, we talked about what a polynomial was. We talked about binomials and trinomials and terms of a polynomial. So just remember, a polynomial is an expression. So I'd like to start off by reviewing combining like terms. So this is something you have learned about and should know how to do. So like terms are terms that have the same base to the same power. So like terms have the same base to the same power. So example, 3x squared and negative 1/2 x squared. Those are like terms. The base is x and the power is 2. Or remember, we called the power an exponent, right? So x and negative 2x, those are like terms. They have the same base to the same power, the same exponent. Go, well, it doesn't have an exponent. There actually is an exponent of 1 right there. And you can have more than one power, more than one base. So 3x squared y to the third and negative 12x squared y to the third. Those would also be like terms. X squared, y cubed, y cubed. So these ones here are like terms. So why don't we do some then that are not like terms? All right. So, in fact, I'm going to do them in red to really contrast that these are not like terms. So 3x and 3y, those are not like terms. Now they both have 3's. Those are the coefficients though. The coefficients are the same, but the bases are different. Or what about 4x and negative 2x squared? Now they both have x's. That's a 2. They both have x's, but the exponent or power on this one is a 1, and the exponent on power on this one is a 2. If we go up one like similar to this, if we did 3x squared y cubed and negative 12x cubed y squared, those are not like terms. Go, well, they both have x and they both have y. That's true, but this is x to the second, this is x to the third, this is y to the third, and this is y to the second. Okay, so like terms, these are, again, examples in blue of ones that are, examples in red of ones that are not. So if you're, in fact, I'm going to erase combining like terms because we were just talking about what like terms were. So to combine like terms, you add, or sometimes the case might be subtract the coefficients. All right, but the bases, and exponents stay the same. All right, so when we're combining like terms, we add, or if the case may be subtract, the coefficients, but the bases stay the same. So just a reminder, the coefficients are the numbers out in front, all right? So for example, I'm going to have the expression 3x squared plus 2x squared. So the coefficients are 3 and 2, and the x squareds here, that's what makes these like terms. So what this really is 3 plus 2 times x squared, or 5x squared. We just combined the like terms by adding the coefficients. Those are the coefficients. Let me try that again. C-O-E-F-F period. So those are the coefficients, all right? Or it might be subtraction, 5xy minus 2xy. Well, that's going to be 5 minus 2xy, or 3xy. Again, we subtract the coefficients. Okay, so the process of adding and subtracting polynomials is the same as the process of combining like terms, because that's what we're doing. All right. Okay, so let's go ahead and take a look. Simplify. By the way, since these are expressions, taking an expression and writing it in a shorter way is called simplifying. So I'm going to simplify. I have 3x squared plus 2x minus 7 plus negative 4x squared plus 5x minus 3. So this is a polynomial with 3 terms. So this is a trinomial. This is a polynomial with 3 terms, also a trinomial. We're asked to simplify, and the operation is addition. So what are we going to do? We're going to look for those like terms. So I'm going to go ahead and color code the like term. So this 3x squared is a like term with this negative 4x squared. This 2x is a like term with this 5x. And this 7, which is being subtracted, is a like term with this 3, which is being subtracted. So what I'm going to end up doing is doing 3x squared plus negative 4x squared plus 2x plus 5x plus a negative 7 plus a negative 3. So again, if we go with color coding, those two getting combined, those two getting combined, and those two getting combined. Whoops, wrong colors. Those two getting combined. Remember, subtracting a positive is the same as adding a negative. Subtracting a positive is the same as adding a negative. So when I put these two together, I have 3 positives plus 4 negatives. That gives me a negative 1x squared, or just a negative x squared, or the opposite of x squared, plus 2x plus 5x gives me 7x, plus negative 7 plus negative 3 gives me negative 10. All right, now to be honest with you, We don't usually write it as plus and negative because it is considered more simplified to write it in this way. The opposite of x squared, or negative x squared, plus 7x minus 10. That would be the trinomial you get when you add these two trinomials together. So this is addition of polynomials, which uses the process of combining like terms. All right. All right, so let's do a subtraction one, and then that will be the end of this video. So here we go. So let's now do a subtraction problem. So again, I'm going to put simplify. All right, negative 4x to the third minus 7x squared plus 2x minus 3 minus 5x to the third minus 9x squared plus 3x minus 12. Okay, so instead of having 3 terms in my polynomial this time, I have 4 terms. My highest degree is 3. We haven't talked about this yet, but this would be a third degree polynomial with 4 terms. This is also a third degree polynomial with 4 terms. Only this time, instead of adding them, we're going to subtract them. All right, so depending on who your teacher has been, you may have learned different ways to handle this differently. One of my favorite ways that I have talked about and students have talked about with me is going ahead and distributing that subtraction. So when you're subtracting, you're not just subtracting the first term, you're subtracting everything. If we were to go back to the previous problem, whoa, where did it go? I think I must have deleted it, huh? So it's not there. In the previous problem, we had addition and everything after it was being added. So we didn't have to worry about distributing an addition because when you're adding, it doesn't change anything. Adding a group of numbers is the same as adding them individually. But subtracting a group of numbers is not. All right, so I'm going to go ahead here and we're going to see what happens when I distribute this. So subtracting a positive 5x cubed is going to be the same as minus 5x cubed. But subtracting a subtraction gives you an addition. Taking away a takeaway is the same as giving it back. I don't know if you've ever been grounded for something where your parents took something away from you. Well, when you got ungrounded, they took away the taking away, and that's the same as giving it back. So this is going to be plus 9x squared. Now we've got a subtraction of an addition. So that's like a negative times a positive is a negative, taking away. And then here's our subtraction of a subtraction again, which is addition. So oftentimes we talk about it, even though technically, mathematically, it's not correct. Like a negative times a positive is a negative times a negative is a positive times a positive is a negative, and a negative times a negative is a positive. But these aren't really signs, they're operations, but it ends up working out the same way. All right, so now I have these ones over here. There's nothing out front, so I'm just going to rewrite this as negative 4x cubed minus 7x squared plus 2x minus 3. All right, here we go. Now that we have simplified that, we are ready to combine like terms. And when I pick these like terms, you'll notice I'm grabbing the term and whatever operation is in front of it as well. All right, so again, these are operations, not signs, except on the first one, but we can treat them as if they're signs, making sure that we do the simplification correctly. So what am I going to get here? I'm going to get negative 4x cubed plus negative 5x cubed Try that again. All right, I'm going to do everything, by the way, with addition. Subtracting a positive, subtracting a positive is the same as adding a negative. I like when I get to this point to change everything to addition, just because I think it makes our life easier. So then plus 2x, and I'm not going to put minus 3x, I'm going to put plus negative 3x again, because subtracting a negative is the same as adding a positive. And then I'm going to get plus negative 3 and plus 12. So here we go. I'm going to combine my like terms here. So I have my negative 4x cubed plus negative 5x cubed. That's going to give me negative 9x cubed. I'm going to have my negative 7x squared. It's this color right here. Plus the 9x squared. What do I have more of? I have more positives. How many more positives do I have? I have 2. And then I'm going to do the plus 2x and the plus negative 3x. What do I have more of? Negatives. How many more negatives do I have? 1. And finally, I'm going to do my negative 3 plus 12, which is going to give me plus 9. All right, and now we're going to clean that up a little bit, because even though I said I was changing everything to addition, when we're done, if we have an adding of a negative, we change that back to subtraction. So my final answer is going to be negative 9x to the third plus 2x squared minus x, because subtracting a negative is the same as adding a negative is the same as subtracting a positive, plus 9. So this 4-term polynomial plus this, not plus, actually minus this 4-term polynomial ends up being this one. We have simplified by subtracting these polynomials. All right, I hope that helps you understand adding and subtracting polynomials. See you next time.